Hello, my name is Ian, and it's been a while, but I'm back to share a project with you, a small hardware project. This is it. It's a little bag of bits. You can get them off Amazon for £5 or so. This particular little kit is a waveform generator. Let's take a closer look at it. So, what I have is a little bag of parts, PCB, resistors, capacitors. It's an NE555 timer in it. So this waveform generator is apparently going to generate square waves, sawtooth, sine waves, and I think square waves. I said that. And what's the other one? I think it's a triangle wave. That's what it is. Inexpensive little kit. We're going to have some fun with it. It's a bag of parts that hopefully looks something like that, although I have no idea yet. That's going to be the first order of business. I will be counting the bits. So let's show you the project first. So this is it. You can buy it off Amazon. This particular one has what do I say there? It's going to look something like that. Some bits and bobs on it. My PCB that I can see just looking at it is similar layout but slightly different. The PCB I've got actually is that layout but different again. The silk screening's a little bit different, but you see here it's we've got a circuit diagram, we've got something to do with oscilloscope showing a waveform it can create. We will be able to look at that as well, because whenever I've got this going I will be testing it with an oscilloscope that I have, an Owon 1022i oscilloscope. We'll be looking at that sometime later. Anyway, I will get on and do the first thing you should always do with the kit of parts. Count your parts, make sure you've got them all, and they all are what you're expecting. For this particular one, I can see that, well, the instructions are just what's on the silk screen. There is no paper with this, nothing. So it is what it is. Gonna have to count them. Anyway, I'll be back when I've counted them. Okay, I'm back. Everything's counted. Everything's there. In fact, more than everything's there. I've got a couple of extra header pins and one extra 473 capacitor. Took me a bit of time to check it out because things are very small, so I have to use a headset. It's a magnifying headset with a light. Without that, couldn't read the markings on those capacitors for sure. Anyway, we're all there. Let's get on with some soldering. I will be building it in stages, and I will come back after each stage. See you in a moment. Hello, I'm back. So, some soldering has been done. All the capacitors and the resistors are on the board. So let's take a look at where I've got to so far. And you can see the board. Everything looks tidy and shipshape. Very handy holder as well for when I'm soldering. And of course again I had to use my magnifying headset to do all this. Anyway, that's where I've got so far. Only the passive components are on, the capacitors and the resistors. I will be back whenever I do some more. Catch you later. Okay, I'm back. All the soldering is done, so let's inspect it and see what we've got. Here we are. I've buzzed out all the connections I think I needed to. The only thing that remains is to put the NE555 in, and here it is. So let's just pop that in. There we go. There we are. All done. So what remains now is, what camera am I on? What remains now is some volts, and let's see what we find, what signals we get, etc. I'll be back in a bit. Hello again. Right, now it's time to put some volts into this thing and check out what we have with an oscilloscope. So let's look at the oscilloscope first. This is what I have. It's a USB scope, so USB in there. I've got probes at this end and I've got a probe. Excellent. Not a problem. Easy peasy. Let's give it a go. So we'll put it out of the way and we'll bring in the star of the show. So this is the waveform generator. We're going to put some volts into it. The volts go in there. The signal comes out there. We decide which signal we want to have, you know, square wave, triangle, whatever, with a jumper on one of these sets of links here. And let's have a general poke around. So let's have a switch to this one. You can hopefully see the scope. We will zoom in on that a little bit, but we'll just do a few cursory checks. First, we'll give it some volts. This is a 9-volt battery. So if I put my ground on this pin, then I can start looking around. So this pin should give me the voltage. I should be seeing up 9 volts, 8 or 9 volts, and yeah, that's jumping up to over 8. It's about 9 when I'm on this side of the diode, yes. So we've got volts into it. Now let's have a look at some signals. So a closer view on that. So let's have a look. We should be on the square wave. So if I look at the output, there we go, square wave. It's telling me the frequency is 1.3, 1.4. It's telling me it's peak to peak of about 1.5 volts. This particular thing is looking like a duty cycle, square wave duty cycle of about 50-50. Seems to be bouncing around. That's probably a trigger problem. That's it. If I clip it on, I can play with it a bit more. So yeah, let's have a look. Yeah, that is looking about 50% duty cycle. The peak to peak voltage is a bit disappointing. I wonder what that pot does. I've got a pot here. Okay, yes, I've lost trigger. So that pot is clearly not the frequency, it's the amplitude. Okay, well, it's 1.5 volts peak to peak is disappointing, but the shape of it isn't bad, and the fact that it's a 50% duty cycle is quite quite nice actually. Let's have a look at the sawtooth. Oh yeah, that's just a capacitor charge discharge cycle that they've called a sawtooth. Again, it's not very big, 1.7576 volts peak to peak. Let's have a look at the triangle. Okay, that is very disappointing, isn't it? Very small. I wonder if we can trigger it a little bit lower. Oh yeah, there's a little bit of a... Okay, well that's hard to trigger. If we go to different volts per division and trigger on something better. Nearly had it. Right, triggering problem there, but it does look like a triangle. Rounded top's not sharp, but there you go. Let's see what the sine wave looks like. Okay, that's actually not a bad sine wave. I get a better triggering on that. Frequency's coming out at 1.4 kilohertz. It's very small 700, no, it's about 3/4 of a volt peak to peak. That's not very much. Let's go back to the square wave because that's the one I'm more interested in anyway. So there we go. Did I miss it? I did miss the jumpers. There we go. Oh, I missed it again. That's better. There we go. Okay, bit sad on the top there, but we're getting 1.4 kilohertz, and this pot, yeah, just affects the amplitude, doesn't affect that slope. I think that slope is because there's a capacitor in there somewhere. Probably that AC decoupling capacitor, which I can see at the output stage just before the pot when I'm looking at the circuit diagram. Wonder if I can poke around anywhere else. Let's have a look at the actual, what does the signal look like on the jumper? I'll jump right up. Let me change the frequency. Sorry, the volts per division. Make it 5 volts. What does that look like? Okay, you know, there's the square wave riding on top of DC, and it's the DC that will get removed with that decoupling cap on the output. Yeah, okay. You should be able to see the sawtooth triangle. It's most disappointing, I think. And the sign. Okay, so apart from them all being very small, which is odd, I mean, there's a nice, beautiful and big square wave coming out of pin 7 off the 555 itself. So I wonder what those two transistors, you'd have thought they'd have been doing some amplification somewhere, but clearly not. I'm not an analog expert. I'm going to have to study that. But there we go. We've got some signal, and we've got some waveforms. And all in all, I'm very pleased with this scope. 1.4 kilohertz, 1.4 volts peak to peak, 50% duty cycle. Oh, I like this scope, I really do. Don't think the frequency's very stable though. Oh well, probably not with that just being RC derived in the first place. Okay, alright, well there we go. If there's any comments, down below please, that's where they go. In particular, if you can give me some pointers on that circuit, which is up there somewhere. If you can give me some pointers in that circuit of why those transistors don't seem to be amplifying and why I'm getting such a small square wave out, I would be grateful. In the meantime, have a great day. Bye.